Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Hello and welcome to Learning Garage. I'm your host, Gaira Babatunde Lamin, and of course we are talking mathematics, and of course we are discussing fractions. Remember, in our last class we dealt with fractions and as well as numbers, okay? And of course we want to move on to our next topic, but before that we cannot just move on. I think for the benefit of those who missed our last class, I would like us to solve at least the problem so that people who missed the last class will benefit from this one today, okay? Of course we move on. We say there's a question which came in the 1992 August exams. It says you're asked to simplify in brackets 3 upon 4 all multiplied by 4 whole number 1 upon 3 divided by 3 whole number 1 upon 4. Okay, don't press the panic button. All you need to do is to relax and pay attention. Okay, mathematics is not going to kill you. The first thing that comes up is what? Our board maths. Okay, board maths. And of course most of us know what's the meaning of board maths. This is the fundamental, or is the basics of you solving any fractions. Okay, our board maths here says what? You have to first consider our bracket, and then of course from there we talk about the off sign. Okay, and then division, multiplication, addition, as well as subtraction. 3 upon 4 in brackets plus our 3 upon 4 plus 1 upon 3. Remember, board math says what? We have to first simplify whatever is in our bracket, then we move on to off, and then we move on to our division signs as well as multiplication, either addition and then subtraction. This order, you have to respect that one. And we are given in brackets 3 upon 4 plus 1 upon 3. Okay, and to solve this part of the problem, let's call this part our A. Okay, A here is what? If we are to simplify, firstly we have to find the least common multiple. That is to say, the least number that 3 and 4 can enter into without leaving any remainder. And that's what are the factors of 3 and 4? Of course, our factors of 4 are what? Plus or minus 1, 2, 4, 8, and so on. And of course, factors of 3 are plus or minus 1, 3, 6, 9, 12, okay, 18, and so on. And of course, it says again, the least number that 4 and 3 can enter into is what? Is 12. Okay, so 12 there would be our LCM. 12 there is our LCM. course, we say 4 into 12 is how many times? 3 times 3 times 3 gives us 9. We bring down our sign, which is positive there, plus, and 3 up into 12 is 4. 4 times 1 gives us what? 4. Okay, so this ends up to be what? 9 plus 4 gives us what? 13 upon 12. Okay, so we have solved just a single aspect of that one. So therefore, by solving our fraction from above, which says what? Our a there is multiplied by 4 whole number 1 upon 3 divided by 3 whole number 1 upon 4, and of course this gives us what? 13 upon 12, okay, multiplied by 4 whole number 1 upon 3, okay, divided by 3 whole number 1 upon 4. Our board maths here says what? Bracket of division, multiplication, addition, and then subtraction. Okay, bracket of division. Okay, before we move on to our multiplication, we must divide there. 4 whole number 1 upon 3 divided by 3 whole number 1 upon 4. Okay, so we maintain our 13 upon 12 multiplied by, we treat this other aspect which says 4 whole number 1 upon 3 divided by 3 whole number 1 upon 4. Okay, so by solving the above equation there says what? 4 times 3 is 12 plus 1 gives us 13 upon 3 divided by 3 by 4 is 12 plus 1 gives us 13 upon 4. Okay, this will give us what? 13 upon 12 multiplied by what is inside the bracket there. If we are to change the division sign there to multiplication, of course we invert. That is to say, we invert what is the denominator becomes the numerator there, which is 4 becomes the numerator, and then 13 becomes the denominator. Okay, and can we simplify further this one? Yes, we can simplify. That is to say, there are common terms for both numerator and denominator here, which is 13 goes into 13 one time, into 13 again one time. So we have 13 upon 12 multiplied by what is in our bracket there. 1 times 4 gives us 4 all upon 3 times 1 there gives us what? 3. We end up having what? Our 13 upon 12 multiplied by 4 upon 3. Okay, so are there any common factors from both our denominators and numerator? Yes, and we have 4 and we have 12. There is a 4 here and there is a 12 here. That is to say, there are common factors, or there are common numbers that can enter into both 4 and 12 without having any remainder. And then we have, of course, 4 can enter into itself once, into 12 3 times. So our numerator has been simplified. That is to say, 13 times 1 upon our 3 multiplied by 3. This will finally give us what? 13 times 1 is 13 all upon 3 times 3 gives us 9. Of course, we can still reduce this one. We have our 13. This is equal to 13 upon 9. How many times can 9 enter into 13? 1 times remainder 4 upon 9. Okay, this will give us our final answer. So always remember, when you are simplifying fractions, make sure you reduce to the least number. You reduce to the least. Okay, you always simplify fractions by reducing it to its lowest term. Okay, so of course I hope you understand, and we shall take a quick break. When we come back and the class continues.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Yes, welcome back. This is Learning Garage and this is mathematics. And as we have explained, and now we are moving on to our next topic. Okay, remember, if you want to be strong in mathematics, you have to have the foundations. There must be laid foundations that you have to move with. Missing these foundations make it very difficult for you to understand mathematics and make it very difficult to understand each and every other bigger topic that will be coming in the future for you. So therefore, we are advising to pay attention as well as to practice. If you don't practice, it will be difficult for you to understand. Okay, so our next topic there is swords. Swords is our next topic, and of course this swords is not the one that you see in the movies where people fight each other, where people stab and so on. And of course this is a mathematical expression for expressing different irrational numbers. Okay, numbers that cannot be written in fractions. Okay, remember, that's why we have spoke about a lot about fractions. Okay, now we are moving to something that is a little bit more complex from fractions, which are swords. Our definitions there says what? They say a sword is a number of the form plus or minus n root of x. Okay, plus or minus n root of x. Okay, where our n belongs to natural numbers. Okay, the n there is a natural number and our x there belongs to all positive integers. Okay, which is represented as q. Okay, our q there, we say what? Our z there is what? Our natural numbers, whereas our q there represents what? The positive integers. I say which cannot be expressed exactly as a fraction of two integers is called a sword. Okay, remember we said things or numbers that we cannot express as fractions. Okay, we leave them in sword forms. Okay, in other words, a sword is an irrational number of the form plus or minus n root of x, such that plus or minus n root of x cannot be written as a upon b, where b is not equal to 0. B would never be equal to 0 because that fraction will be what? Undefined. Remember, we spoke about those type of fractions in our last class. Okay, there can be only undefined fractions when the denominator there is equal to 0. Therefore, for example, we said what? The root of 2, the root of 3, 3 root 4, sorry, the cube root of 4, the cube root of 4, and the fifth root of 7 are swords because they are irrational numbers and cannot be written as exact ratio of two integers. Okay, whether be it positive or negative integers, they cannot be exactly written in ratios of integers. Okay, of course these approximations can still be obtained using calculators or other suitable means. Okay, it doesn't mean that when you cannot express swords in different forms by calculation, but yet still you can use your calculator or any other form at which you can simplify our swords. Contrary, we say root 3, root 36, cube root of 27, and the fifth root of 32 are not swords. What do we mean by this? Okay, let's say for example the root of 36. Okay, Root of 36 here gives us what? We have to express this one. It says what? Our 6 multiplied by 6 gives us 36. 6 there, our 36 there is a perfect square. It means that we can say 6 raised to the power 2 all under the root is what is equivalent to the root of 36, meaning our 6 raised to the power 2, if we replace our square root term there, our square root symbol there, it can be also represented as to the power of half. Okay, simplifying this one gives us what? 6 raised to the power 2 multiplied by half, which gives us what? Our 2 here is common here, our 2 here can cancel this one, so you are only left with what? 6 as a single digit. So it means that this man 36 is not a sword. Okay, the root of 36 is not a sword because you end up having a whole number. Any sword that is reduced in a way that you end up having a whole number, then that one is not referred to as, or that particular number or set of numbers are not referred to as swords. Okay, another example there is the cube root of 27. The cube root of 27 says what? Is 3 multiplied by 3 multiplied by 3 all under the root gives us what? 3 times 3 is 9 times 3 again is 27. Okay, representing this in a more reduced form, you have 3 raised to the power what? 3 all raised to the power what? 1/3. Okay, 1 upon 3. So reducing this gives us what? 3 raised to the power 3 multiplied by 1 upon 3. Our 3 there are common, so 3 and 3 will cancel, and then we end up having 3 again. If you have 1 times 1 is 1 upon 1 is the same as 1. So therefore our value there is a whole number, and therefore this is not a sword. Okay, remember we said swords are values or numbers that can be represented or can be written in an irrational form, meaning you cannot reduce that irrational number, okay, or set of numbers into fractions. Okay, another example again is the 5th root of what? The 5th root of 32. Okay, it's the same as what? Our 2 times 2 times 2 times 2 times 2. Okay, 2 times 2 gives us what? 4 times 2 8 times 2 16 by 2 gives us 32. So therefore we can represent this in a simple form in a way that we say our 2 will be raised to the power. How many times does 2 multiply itself? 1 2 3 4 5. Okay, that is 2 raised to the power 5 all raised to the power 1 upon 5. Okay, again this one can be written as what? 2 raised to the power 5 multiplied by 1 upon 5. Okay, we are in 5 and 5 common, and it nullifies, it becomes what? We are only left with 2. Okay, so therefore this is not a sword. We move on. I say in swords operation, how do you operate swords? It is often common to see only cases where n is equal to 2 in the form of our man here, which says n root x. N root x. Okay, the n of the is there. The n there is 2, and of course 2 normally we don't represent because the square root there represents the 2. Okay, the square root there represents, of course, square root is 1 upon 2, wherein the 2 there is invincible, so therefore we only leave it as the root of what? X. Okay, which is generally written that way. So therefore this where x is equal to 2 is an example of a quadratic sword or a quadratic irrationals. Okay, in similar terms we have cube roots. They are called what? 3 root x is called what? The cube root. 3 root x there is called what? A cube root there. Okay, so now let's having having known all of those simple things in swords, let's talk about the similarities or similar swords. Okay, when we say swords are similar, you mean that what is under the square root sign there, okay, the number or the value that is under the square root there should be what? Equal. What are we saying? And two quadratic swords plus or minus the root of A and plus or minus the root of B are said to be similar only if their radicands are the same. Okay, that is to say the value that is under the square root term there, under the square root symbol there, are the same. Okay, we say that is to say if A is equal to B, suppose we have root of 2 plus or minus the root of 2, comma, and then we have plus or minus the root of 3. Okay, looking at these two, we are saying that they are not the same. Okay, if you have a sword that have two different values, okay, under the square root sign there, we are saying these swords are not equal. Okay, that is 2 is never equal to 3. Okay, suppose we have root 2, okay, of course is equal to what? Root 2. Okay, again, if we have root 5, okay, plus 3 root 5, of course what is here is equal to what is here, so therefore we say these are similar swords. Okay, these are similar swords. So we say again, in general, two swords, whether be it quadratic or otherwise, and the form plus or minus n root A and plus or minus m root B are said to be similar if and only if, okay, if A there is equal to B, okay, then they are similar swords. Okay, only if their radicands are equal, that is A is equal to B, and then again the power there on top of the root sign, which is m, must be equal to n. Okay, if we have example, what we are trying to say, if we have 3 root 5 plus we have cube root of 5 again. Okay, of course we can add or subtract this one as the case may be. Why? Because they are similar, because what is underneath the square root sign, what is underneath the square root there is 5, and what is the power, okay, or what is the root of that particular sword there is 3. So therefore these two swords are equal. Okay, let's take a quick break, and when we come back we shall discuss the rules of swords.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credit on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcast are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Welcome back. This is Learning Garage, and we are discussing mathematics. In mathematics, we are talking about sorts. Okay, our operations, we are talking about the operations of sorts. How can we represent our sorts? How can we move about sorts? Okay, and we have spoken that we have talked about the definition, and of course we said sorts, these are irrational numbers that cannot be expressed as a fraction. Okay, otherwise we leave them in those root form. And now let's talk about the rules. How do we go about sorts? And as we see here, we have our first one there says what? The root of a b. The root of a b. Okay, the root of a b. Okay, ab is the same as the root of a multiplied by our root of b. Okay, this is distributive, meaning you can apply the law of distribution to what? To separate the values that are underneath our sword. Okay, that is to say the root of ab is equal to what? The root of a multiplied by the root of b separately. Okay, that is one. Second one says what? Root of a multiplied by the root of a gives us what? A. At any time you multiply sorts that are similar, that is to say they have the same value or the same base underneath. Okay, suppose we have root 2 multiplied by our root 2 there. Since the base there are the same, 2 and 2 are the same, so therefore we can nullify the roots. Okay, root 2 multiplied by root 2 gives us what? 2. Okay, similarly, so if you have root 3 multiplied by our root 3, it gives us what? 3. Okay, our third man there says what? When we have the root of a divided by the root of b, this is equal to us similarly so as having all of the values a and b under our root. We apply the inclusive law, meaning what is on top, what that is to say the numerator there and the denominator does all apply or does come under the square root there. And similarly so we can represent this as what? The root of a divided by the root of b, all under the square root rather. Okay, and let's see some examples so that we can understand more better. You are asked to simplify one root of 12. Okay, you are asked to simplify the root of 12. 12, you think about numbers which are factors of 12 that are somehow perfect squares. Okay, find numbers which are perfect squares that you can multiply to give you 12. What are those factors? 2 and 6. 2 times 6 gives us 12. But is 2 a perfect square? No. Is 6 a perfect square? No. Okay, so it does not apply in this case. And we have again 1 times 12 give us 12. Of course 12 we are trying to simplify. 12 there is not a perfect square. So we find two numbers which are perfect, at least one of them is a perfect square. That is to say, what are the factors of 12 there? We say 4 multiplied by 3 gives us 12. 4 times 3 is 12. And 4 there is a perfect square, meaning this is also expressed as the root of 4 multiplied by the root of 3. Okay, remember from our basic rules it says what? Whenever you have multiple of numbers under the same root, you can distribute them. Okay, so that is to say our 4, the root of 4 times 3 is the same as what? 4, the root of 4 multiplied by the root of 3 separately. So therefore our 4 there is what? Is a perfect square which can be written as what? 2 raised to the power 2. Okay, all under our roots there. multiplied by root 3. Can we find two numbers that we can multiply to give us 3? The only two numbers, which is 1 and 3. Of course, we are not interested. 2 raised to the power 2 is what? Is the same as what? 2 times 2, which gives us 4. Okay, so we can still represent this. To simplify, again, we say 2 raised to the power 2 all raised to the power half. When we change our square root sign there, we take it to be raised to the power half, all multiplied by the root of 3. Okay, so if we simplify this one, we have what? 2 raised to the power what? 2 multiplied by 1 upon 2, all multiplied by what? The root of 3. This gives us what? Can we simplify the fraction that is the power there? Yes. How? 2 is common on both denominator and numerator there. So 2 and 2 cancels. We have what? 2 raised to the power 1 multiplied by our root 3. Okay, this gives us what? 2 raised to the power 1 is the same as 2 multiplied by root 3, which is the same as 2 root 3. Okay, so this gives us our final answer. The final answer there for root 12 says what? Is 2 root 3. We are taking our time to explain this one. When we move in further in advanced natures, okay, in advanced form, we don't have time to explain some of these steps, because mathematics is all about speed and accuracy. You have to move fast and you have to move with accuracy. Okay, you have to minimize the errors. So we take another example. Example 2 there says, yeah, so to simplify, the root of 10 multiplied by the root of 5. So similarly, we try to break down the values that are underneath our square root terms. Can 10 be simplified? What are the factors, or what are those two perfect squares that we can multiply to give us what? Our root 10 there. What are these factors? Our 10 there would be represented as what? 2 times 5. Okay, all multiplied by the root of 5. This is also equal to what? Say our root 2 multiplied by root 5, all multiplied by our what? All multiplied by okay. So if we are multiplying, remember we said when we are multiplying similar sorts, when we multiply similar sorts, we look for the values that are underneath the square root terms that are similar. Okay, so that is to say root 5 multiplied by root 5 there is what? Is 5. Okay, multiplied by what? Root 2. Okay, so we end up having 5 root 2. Okay, 5 root 2 gives us what? The root of 10 multiplied by the root of 5. Okay, I hope we all understand. And we take one last example. Okay, we are looking forward to a last example, and then we leave you with some problems to solve. Okay, the next question says what? You have to simplify the root of 12 upon the root of 6. The root of 12 all upon the square root of 6. Okay, now again we apply the same rule. We have 12 there. 12, we have to scatter that one so that we can have factors that are perfect square that we can multiply and break it to a simpler sort form. Okay, root 12 there, it says what? 4 times 3 all upon the roots there gives us what? 12. And therefore 6 again. We ask ourselves the questions, what are the factors of 6 that we can simplify this one? The factors of 6 are what? Are 2 multiplied by 3. Okay, so if we simplify this one, our numerator there becomes what? 2 root 3 all upon our root 2 multiplied by root 3. Okay, root 3 again, we say again our root 2 multiplied by our root 3. Can we further simplify? Yes, we can. And of course, for our numerator there, it was what? 2 multiplied by the root of 3 all upon root 2 multiplied by root 3. Okay, if we simplify this one, we are going to have common values. Okay, that is to say our root 3 there is common in the numerator, and as well as it is common for both denominators. So therefore they cancel out, and we have 2 upon root 2. Okay, so this is the same as 2 divided by root 2. Okay, so ladies and gentlemen, I hope we've all understood what we have been talking about, and of course I'll leave you with some problems to solve, and please make sure you solve these problems so that you can have a full and better understanding about the topic. Yes, so ladies and gentlemen, we have some problems here for you to solve, and after which in our next class, when we meet again, we are going through those questions, we solve them together, and then we move on. I've been your host, Gaira Babatunde Lamin. Thank you very much for paying attention. This is Learning Garage. Stay tuned.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction.